You are welcome to Tema Secondary School, SHS 1 Chemistry. Our topic for today is chemical bonding. And then we'll look at, for today, we'll look at just one part of it, that is interatomic bonds. Our objectives for today find out what bonds are, why do atoms, ions, or molecules form bonds? The type of bonds, or the types of interatomic bonds. And then 4, the properties of the ionic, covalent, or metallic substances as a result of the type of bond that they form. Right? We'll begin by looking at some introduction. What are bonds? That would be the first thing that will come to mind if you ask what a bond is. Right? A bond could be described as anything that holds two things together. Right? It could be as big as between you and your parents, or between two countries. Right? Or between two atoms, or ions, or molecules. Right? Now, if a bond exists between two entities, let's say atoms, such a bond is what we call interatomic bond. Right? You can also have bond existing between two or more molecules. In that case, we refer to that bond as intermolecular bonds. Right? Because interatomic bonds exist between two atoms, we can also refer to them as intraatomic bonds. So they have bonds can be grouped into two interatomic bonds and intermolecular bonds. The interatomic bonds are also known as intramolecular bonds. Right. Now, for example, if I have a substance, let's say water, for example. Water. How is water formed? Water is formed when you have two hydrogen atoms combining with one oxygen atom. That gives a water molecule. Is that okay? Now, within the water molecule, we can have the water molecule themselves also combine with each other. Right? So if I have two H atoms combining with one O atom, that gives water molecule. The atoms are able to come together to form water because there's that attraction between the two atoms that gives rise to the water molecule. Right. If I have those water molecules also in the form of a liquid, then I expect that there's a bond that will be between the molecules themselves. In that case, within the water molecules, you will not find interatomic bond, but you find intermolecular bond. Because there you're looking at it as a molecule. Is that okay? So the essence of bond formation is for atoms to come together to achieve a stable outer inert gas configuration, right? Which is either 2 or 8, right? And that is what we call the Lewis duplet or octet rule. Now, for the various bonds, if I have, let's say, a sodium atom combining with a chlorine atom, that gives a molecule of sodium chloride. Is that okay? Yes. Now, if the species combining are ions, then we realize that the type of attraction that brings the two entities together is now what we call the ionic bond. Is that okay? Yes. So by ionic bond formation, you have the compound NaCl4. If I have, let's say, hydrogen and a hydrogen combining together, that will give me H2. Now, if these two species coming together are not ions, let's say they are atoms. In this case, what is formed is what we call the covalent bond. Right? Then likewise, if I have just a metal, let's say a solid substance, let's say sodium metal, for example, or sodium metal, because it's not a combination of any other substance. The only entities you find there are sodium atoms. But we expect that it forms the metal because the atoms will give rise to the ions, and the ions in a sea of delocalized electrons. So the attraction between the positively charged sodium ions and the electrons give rise to that type of substance, what we call the sodium metal. So the bond you find in the sodium metal is what we call the metallic bond. Right. So the three main forms of the interatomic bonds we want to discuss today are the ionic bond, which is also known as the electrovalent bond, the covalent bond, and then the metallic bond. Is that okay? Now, to illustrate all that we just said for the three, let's see the first one. If you take the sodium ion has a nucleus, right? And then, because bonding is a chemical property which has to do with only the valence electron, you can look at the sodium ion in the electrons only on the valence shell. Is that okay? Yes. That is, if the sodium atom has lost just one electron, right? That gives the sodium ion. So we have the sodium, and then this becomes the chloride ion. So let's say this is positively charged and this is negatively charged. The two species are able to come together by that force of attraction between the positive ion and the negative ion. So that results in the formation of the sodium chloride. Right? So we can call this one the sodium chloride. Is that okay? Then if I have the atoms, if it's the hydrogen atom, one hydrogen atom, and another hydrogen atom, because here they are not ions. Is that okay? What we expect is that on the valence shell, since they have just one electron on the valence shell, when they come closer to each other, they only have to share the outermost electrons in order for them to achieve stability. That is with 2 electrons on the outermost shell, right? So that means that the orbitals or the shells of these two atoms must overlap, right? And the electron share between them. So you have this and this. If the electrons are shared between them, they give the H2 molecule. Is that okay? Then you take the third type. If you just take a solid substance, let's say a metal, then we are saying that the sodium ions will be in a sea of delocalized electrons. And that attraction between the sodium ions and the electrons results in what we call the metallic bond. So a metallic bond is not formed between any two different species, but the ions of the metal and the electrons within the metal, which attract each other to give rise to the bond. Is that okay? So these are the three main types of the interatomic bonds. But we'll focus on the first type today, which is the ionic or the electrovalent bond. Is that okay? Yes. Now, what did you say? Why do atoms come together to form bonds? What's the reason, the essence of bond formation? Why should bond be formed? Yes.
Bonds are formed in order to get a stable electronic configuration.
Yeah, bonds are formed in order to get a stable outermost electronic configuration. Is that okay? So if two or more atoms or ions come together and they form a bond and they have 2 or 8 electrons in the outermost shell, that means that they are now stable and they can exist in that form. Is that okay? So it is, if you find sodium atom or sodium in nature, it will not be in the form of a sodium atom, because in the sodium atom it will not be stable. So those electrons or the electron might be lost to another atom in order to achieve that stability. So if you find sodium in nature, you might find it as a compound or as a molecule, either as sodium chloride or any other combination, any other element, right? Likewise, let's say the gases. Even if you take the monoatomic gases, let's say the rare gases, even though they are monoatomic, let's say helium for example, helium can exist just as this, because it will not combine with any other substance. But within the helium molecules, we expect that helium is a gas because the molecules are also able to attract each other to give rise to that. Is that okay? So those are the reasons why bonds are formed, to achieve stable outer electronic configuration. Right? Any question? Before we move to the ionic bond, yeah.
Sir, please, why is it that when 2 ions are forming a bond,
yeah,
and after forming the bond, why is it that their charges are not written?
If 2 atoms form a bond, why is it that the charges are not written?
Yes.
Right. For example, the sodium chloride.
Yeah. Which where the sodium is positively charged and the chlorine is negatively charged.
Yeah. If I have sodium ion plus a chloride ion, the compound form should be NaCl. Is that okay? Right. Because the charges are not written because the charges must cancel out. Right. So if you have equal number of positive charges here, equal number of negative charges here, the 2 charges will cancel out, giving rise to a neutral entity. Is that okay? But the person demands that we should give the structure of the compound in this ionic form, which will be the same as what? So you can write it as Na plus and then Cl minus. Is that okay? But usually we don't bring the charges because we expect that before the compound is formed, the charges will balance out. In that case, the whole compound becomes neutral. In that case, the compound is stable. Is that okay? Any question? Any further question? Okay. If there's no question, let's move on. Also known as electrovalent bond. So first, we'll look at definition. How do we define that? Now, an ionic or electrovalent bond is simply defined as an electrostatic force of attraction between 2 oppositely charged species. That is between a cation and an anion. Right. Or simply put, it's a force of attraction between an electropositive element and another electronegative element. Is that okay? But what we take into consideration is that the first element, the electropositive element, which is usually the cation, must have a low ionization energy. That is what? The energy required to remove an electron from that atom should be very small. Is that okay? And then the other species, which form the bond with this one, which is the electronegative species, must have, which is the anion, must have high electron affinity. Because if this one is supposed to lose the electron must be accepted by the second one. In that case, if this one loses the electron, this must have high electron to accept that electron that will be lost. Is that okay? So for example, we take the formation of sodium chloride, which is also known as common salt or what? Or rock salt. Is that okay? Now, the ions that must come together are the sodium ions and the chloride ions to form sodium chloride. Is that okay? But let's look at how this takes place. Now, within the neutral atom, there is sodium. Let's say the sodium atom, which is a period 3 element, and therefore have 3 shells. Is that okay? So we have configuration wise will be 2, and then 8, right? Then the last shell takes just 1 electron. So for sodium, configuration will be what? 1s2, 2s2, 2py, 2pz, and then 3s1. Is that okay? Then for the chlorine, it's also a period 3 element, so we expect 3 shells in that. Is that okay? 1, 2, 3. Because the 2 atoms are not the same. If you use crosses for electrons in this atom, you can use bullets for electrons in the other atom. Is that okay? So we have the first shell takes 2, second shell takes 8, and the third shell takes 7. Right? So the electron configuration becomes 1s2, 2s2, 2ps, 2py, 2pz, 3s, 3s2, 3py, 3pz1. Is that okay? Yes. So for the ionic bond to be formed, since this has a low IE, this has a high electron affinity, we expect this electron here to be lost to that species. Is that okay? So this electron will be lost to this, and that will result in the formation of, when this atom's electron is locked in this atom, then we are left with just 2 shells in this atom, and this atom becomes positively charged now. Is that okay? So we have just nucleus, first shell, second shell. And the number of electrons lost is indicated by the number of positive charges you place on the ion form. So if the species loses only 1 electron, then you place a charge of +1 on this. So you're left with 10 electrons in it. So the configuration now becomes, it will become Na+. Is that okay? Which will be 1s2. So you can write 2 and then 8. That is this orbital electron is gone. Is that okay? Right. Then when we come to the chlorine, for example, this has also increased electron number because this electron will be lost to the chlorine. Is that okay? Yes. So this will become nucleus, first shell, second shell, and then we have the third shell. Right. So this will be 2, this will be 8, and this also will be 8. But this one is not coming from chlorine, so we indicate this with the cross. Because this has also gained 1 electron, the charge on this will become -1 or -1. Is that okay? Yes. So the configuration for this 17 will also become 2, 8, 8. Which you can also write the detailed one as this, the same thing. Is that okay? Now, what will bring the bond between the two? Because the 2 atoms or the 2 species are now oppositely charged. There's a positive charge here, there's a negative charge there. So we expect that the 2 cannot attract each other by that electrostatic force of attraction. Right. And that electrostatic force of attraction is what we call the ionic bond. Is that okay? So we expect that the species should be held closer to each other, and that will form the NaCl. So that is how NaCl is formed.
Thank you.
Okay? Any question on that? Yeah.
Is the laughing gas a bond?
Is there
The laughing gas a bond?
is a laughing
Gas.
gas
A bond.
a bond?
Yes.
So if it's a laughing gas, then it should be a compound. Then within that compound, there should be bonds. Is that okay? Because we said that if not because of bond formation, there will be nothing like oxygen that we breathe or water that we drink. Because the 2 atoms, if the hydrogen and oxygen atom were to exist on their own, there will be nothing like water. Unless they come together to form the bond. So if a laughing gas, if it's a gas, it means that some species must come together to form the gas. So therefore there should be bond between the atoms within that gas.
Okay, if so,
Yeah.
then how is it formed?
How is it formed? Right. If you take then what she was asking for, maybe laughing gas, that is N2, N2O. Is that okay?
Yes.
Now the bond in this may not be, it may not be ionic because the N and the oxygen, the species for ionic bond formation, one must be what? Less in low ionizing energy, and one must be high in electron affinity. If we take the two species there, they are all on the far right of the periodic table, which means that they should all have high electron affinity. So if there's any bond between these two species, it's going to be a covalent bond.
Yes.
Which we'll look at in our next lesson. Is that okay? Right. So for ionic bond to be formed, it must be between a metal and then a non-metal. Right? So it is start between a group 1 element and a group 7 element, or group 2 element and group 6 element, or group 3 element and group 5 element. Is that okay?
Yes.
So let's illustrate one. Illustrates the formation of magnesium oxide. Magnesium oxide. Yes. Anybody could come to the board and illustrate that one. If you follow what we just done on the sodium chloride. Yes. Magnesium chloride. How is it formed? Sorry, magnesium oxide. Is it first? Let's find out. Is it ionic compound?
Yes.
How do you know it's ionic?
Magnesium has 2 plus and oxygen has 2 minus. So you cancel out to create a neutral ion.
How do you know that magnesium has 2 plus, a child of 2 plus?
But it has the outermost shell of magnesium has 2 electrons.
Yeah.
The outermost shell of oxygen has 2. It does not have any beta, it has only 8, but it has 6, but it will receive 2 to make it.
Yeah, so what he's trying to say is that magnesium has a low ionizing energy. So you can lose the 2 outermost electrons, which are not strongly held by the nucleus. Is that okay? But the oxygen cannot lose those 6 electrons because they are strongly held by the nucleus. So therefore, to rather accept 2 more electrons to achieve stable inert gas configuration. So we expect that the bond in this structure should be ionic. Is that okay? So somebody should illustrate for us how that bond is formed. How the ionic bond will come to the bond. Bond to the ions. How the ions are derived and what brings them together.
So taking magnesium first, it has 12. So the electronic configuration is 1s2, 2s2, 2p s2, 3p1, 2p z2, 3s2, and oxygen is 8. Minus 2, 2s2, 2px. Yes, ma'am. Now, this has 12 electrons, and the valence shell has 2 electrons, which does not make it stable. And this has 8 electrons, and the valence shell has 6 electrons, which does not make it stable. Now, for this to become stable, it must lose these 2 electrons here to make it stable. And for this to become stable, it must gain 2 electrons. So now, let's take the magnesium. This is the nucleus. So you can get this like a cross. This has 2. oxygen. It has 2. And it has 6. Now, when the bond is formed, this must have a low ionization energy and this must have a high electron affinity. So now, when the bond is formed between this, it becomes
Can you do the electron transfer? Not an electron transfer. How is the electron transfer? The electron transfer. Okay,
so this electron.
Just do the electron transfer. Not the arrow.
So the 3 electrons move here and they become across here. So now it becomes this.
Hey, allow me. Yes, go on.
So this becomes and this becomes
Take it, that's that.
its charge. So this between these 2 electrons, it becomes 2 plus, and this goes 2 electrons, it becomes 2 minus. So the bond between this is ionic bond.
Yeah, clap for him. Okay. But here, they didn't send electrons to the shell. Is that okay? In the oxygen, there are only 2 shells. Because a period 2 element. So the electron must go to the shell. And then they have 2. So there should be 2 arrows. Is that okay? That's send all the 2 electrons there. But you don't put the electrons here. The electrons will not appear here, but rather appear here. Is that okay? And that attraction between the 2 gives rise to the ionic bond. So the configuration for this will now be Mg 2 plus, isn't it? With configuration 2, 8, or 1s2 and the rest. Is that okay? And this one becomes O2 minus with configuration 2, 8. So that the compound form is what? MgO, right? MgO. In the ionic form, it will be Mg 2 plus O2 minus. Because the 2 charges cancel out, the compound is expected to be a neutral compound. Is that okay? Right. The bond is formed, or the electrovalent bond is formed. In some cases, we can also refer to the same bond here, or what the attraction that brings the 2 ions together is an electrostatic force of attraction. Is that okay? Because the 2 ions are oppositely charged. If the 2 ions were to be negatively charged, they will not be attracting each other at all, because they have the same charge. But because they are opposite charges, they will be able to come together and then form the molecule. Is that okay? Right. But if you have, let's say, the last one, formation of magnesium chloride. Now here too, the magnesium is expected to lose 2 electrons to that species, or the chlorine. But the chlorines must also be 2, because 1 chlorine can accept only 1 electron. Is that okay? So we expect that if it is the magnesium atom, that is 12 electrons. Let's say 8. And then this is 2. And then we have the chlorine, 1 chlorine, which is 17, right? And then the other chlorine, also 17, right? So this is 2, a bullet 2. 8, and then 7. Is what? It's not up to. It's not up to 7. Okay, 1 here. Is that okay? So we expect magnesium to lose 2 electrons. The one will go to that chlorine, another one will go to this chlorine. Is that okay? So at the end of the day, the outermost shell will be lost. So this will be left with just 2 shells with 10 electrons. Right. So this is magnesium ion, and this is Md2 plus. Then this will be 2 chlorine ions, chloride ions. Is that okay? So we expect them to have what? 8 electrons on the outermost shell. Right. So this is 1, 8. And then it's across because this electron is coming from this one. Is that okay? But because they are 2, because these are 2, but don't forget the charge on this, each of them is just -1 because they accept only 1 electron. Is that okay? So this is -1, but because they are 2, we put a big 2 in front. Is that okay? So you beat the attraction between the 2. So this is where the ionic bond is. So in that case, for magnesium chloride, it's supposed to be between magnesium ion, right, plus 2 chloride ions, and that gives NaCl. Is that okay? So it is aluminum chloride because the chlorine cannot accept more than 1 electron. We need 3 chlorine to accept the 3 electrons of aluminum to form the aluminum chloride. Is that okay? Yes. Right. So you can form ionic compounds between group 1. So let's take note of that. Group 1 and group what? 7. They can form ionic compounds. Group 2 and group 6 elements, right? Group 1 and group 6 elements. And then it can also be between group what? Group 3 and group 5 elements. What you have to take note is that it must be between a species with what? Low IE and that species with high electron affinity. Okay. Any question?
It's why is it that the atoms forming the bond, when they are written first, they are not put in a square bracket, but after the bond is formed in the illustration, they are placed in a square bracket.
Yeah, because before the bond is formed, right, the atoms are neutral. They have no charge on them. Is that okay? But after the bond is formed, they are no more atoms, but they have now become ions. If they are positively charged, they are cations. If they are negatively charged, they are anions. Right? So therefore, we must put on each of them the number of electrons lost or gained. Is that okay? So we put the bracket. When we don't put the bracket there, it appears as if the electron loss is only on the valence shell. But the bracket tells you that the whole species has lost the electron, and therefore it's no more an atom but a charged atom. In that case, an ion. Is that okay? Right. So the number of electrons lost or gained is indicated by the number of positive or negative charges you place on the species. Is that okay? Any questions? Yeah.
Sir, please can ionic bond be formed between sodium and sulfur?
Can ionic bond be formed between sodium and sulfur? 16. This is a group 1 element. This is a group what?
6.
Yeah, 16 should be a group 6 element. Is that okay? Now, the reason will be because this can lose just 1 electron. Is that okay? And this can gain what? 2 electrons. Is that okay? So unless you have 2 sodium losing 2 electrons to the sulfur. Is that okay? That will result in, let's say, Na2S. In that case, that will be ionic. because the two sodium can lose the two electrons to the sulfur. Is that okay? But usually, if you have, let's say, H2S, that should also behave the same way. Is that okay? But it depends on the other species. If the first species has a low IE and the other one has a high electron affinity, then it can easily form a new compound. Is that okay? But if the other species also has a low electron affinity, that means that the two cannot easily form a new compound. Is that okay? Even though they will form, but it is not feasible. Okay. Any other question? Any other question? Yeah.
What's the difference between a sulfate and a sulfide?
A sulfate and a sulfide. Now, a sulfide is sulfide. When a species loses electrons, when a species gains electrons, that forms the electronegative species. So a sulfide should be S2 minus, because it's the one gaining the two electrons from the other species. Is that okay? The one is a sulfate. A sulfate means that there's already, the sulfur has been bonded to oxygen atoms. Is that okay? So a sulfate should be SO4 2 minus. In this case, this is an anion and this one becomes a radical. So a sulfur is an anion and a sulfate is a radical, or a group of atoms in the same charge. Is that okay? Yeah. Before we move to the structure, the lattice structure of the ionic compounds, how do they look like? Any other question? Okay, so let's look at that. It means that within every ionic substance, we should expect only ions there. Is that okay? Now, so the arrangement of the ions in the structure gives rise to what we call the crystal lattice. The crystal lattice. Now, in any ionic compound, let's say for example sodium chloride, right? If you have a sodium ion in the middle, or let's say in that geometrical form, you should have other 6 other chloride ions bonded to it, and we refer to that as a 6-6 coordination, or 6-6 coordination, right? So let's just take a unit lattice for that. What I mean by that? If I have, let's just take a unit lattice. That is for sodium chloride, right? Consider sodium chloride. That is, every sodium ion has 6 chloride ions surrounding it. Is that okay? So we have right. So for example, if I have let's say this is a sodium, okay. Let's say the block bullets refer to sodium, right? The solid bullet refer to sodium, and then the hollow ones refer to the chloride ions. Now, it means that if it's a 6-6 coordination within the crystal lattice, you expect the sodium ion surrounded by other 6 chloride atoms or ions. That's 4, right?
Yes.
2 more. This way. Is that it? Yeah. Then, which means that throughout the structure, if I have a sodium ion located in the middle, that should be surrounded by 6 other atoms. Or that results in what we call a phase-centered cubic lattice or structure, right? So for any ionic compound or sodium chloride, lithium chloride, or any other ionic compound, there should be a 6-6 coordination between the positive ions and the negative ions. Is that okay? So the units occurring within the structure, or what we call the crystal lattice, are this kind of species surrounded by that number of ions. If it's a chloride ion in the middle, that should be surrounded by other 6 sodium ions. Is that okay? So that gives a crystalline structure to the ionic compounds. So a layer, or this can form a layer. This could be one layer on another layer and then on another layer. So we have the crystalline structure in the form of layers. Is that okay? So if you have to cleave any ionic compound, you realize that the cleavage happens along the layers, right? So they break in that kind of flat order, right? Giving rise to. So the units within the ionic compounds are the crystal lattice, which is this is case-centered crystal lattice, right? Okay. Why is it 6? The condition number is 6 is because we expect that if you have just one sodium ion there, it should be surrounded by 6 other chloride ions. Is that okay? Probably maybe the chemical structure is not working, but that should be exactly how it should look like, right? Within each, so that here may be another sodium somewhere. So at each vector here may be a sodium. This will be a sodium. If the structure should continue, all the sodium ions must also be surrounded by other 6 chloride ions to give the whole structure, right? This is just one phase taken out. A whole lot of this put together will give the whole structure for the ionic compound. So that makes ionic compound lose crystalline in nature. Is that okay? And then they are flat crystalline substance which can be cleaved along those surfaces. Right? Okay. Any question on the units of the lattice side? We will move on, we will look at the properties. And we finish on the ionic bond. Any question? Okay, let's look at the properties. What are some? I think with models we'll illustrate this. Maybe our next lesson we'll try and illustrate how this is. Everybody will try it and then see how the structure will look. Yeah. Properties of the ionic compound. Yeah. Good.
Enthalpy energy.
They have
Enthalpy energy.
They have enthalpy energy. What does that? What are you trying to say?
Enthalpy energy is the heat given off when one mole of gaseous when one mole of crystalline structure is formed from these gaseous ions, or is the energy absorbed when one mole of is the energy absorbed when the one mole of the crystalline structure is broken to form these crystalline ions, gaseous ions.
But what you are saying is not exactly a property. It's trying to give us an idea about the energy change that takes place before the ionic compounds are formed. Okay. Just as we just look at all of them. For example, what we call the enthalpy changes. So let's look at it before we come to that, the properties. Now, enthalpy changes are just the energy changes that take place leading to formation of any compound. Is that okay? So for example, if you are saying that sodium ions plus chloride ions give us NaCl, it is not just adding this and this to form this, but there are so many energy processes that take place which gives rise to the formation of this. Is that okay? Now, the first one maybe probably could be if I have the sodium metal, that is solid. Sodium should be a solid substance, it's just a metal. Is that okay? Plus a chlorine, which is should be a gas. We need just 1 mole and a half mole of this to form sodium chloride. Right, which is also going to be a solid. But this reaction cannot just take place because we want the compound to be formed in the ionic form. Is that okay? So we should be able to convert the two species here into the ionic forms in order for them to combine each other electrostatically to form the sodium chloride. Is that okay? So in the first case, the sodium atom here must be converted into the gaseous state. We always say that if you are doing energy changes, you are dealing with the atom in the isolated gaseous state. Right? So we convert the sodium, solid sodium into what? Gaseous sodium. By doing what? This could be a simple process of sublimation. Solid to that is sublimation. Is that okay? Or you can also call it enthalpy of atomization or enthalpy of sublimation. That is, you convert this from the solid state to the gaseous state. That will give us Na gas. Is that okay? Now we want the ion form of this, not the gaseous form of this. So we need energy to remove an electron from this to convert this into ions. And that enthalpy change becomes what we call the ionization energy. Is that okay? So here is ionization energy. That will convert, remove electron from this to give us Na plus. Is that okay? Which is a gas now. In this form now, it can now combine with chlorine also in this form to form the sodium chloride. Is that okay? So we expect the chlorine also undergo the same process. But this is a gas already. So there's no need for this subliming. So this only has to atomize or to convert into atoms. Right? So we can call this one another enthalpy of atomization or just enthalpy of dissociation. Because you are breaking the bonds in this to form just an atom. Right? That will give a Cl gas. Then the Cl gas, because this is high electron affinity, it rather accepts electron. So the energy change for this process is going to be what? Electron affinity, right? So by electron affinity, the Cl will become Cl minus gas. Then the two can now combine by another energy change, what we call the lattice energy. So by lattice energy or lattice enthalpy, these two gaseous ions will react together to form the NaCl. But the overall, what we want to achieve is to form NaCl from these two species. So this one becomes enthalpy of formation of the NaCl, right? So this is a simple illustration of what we call the von Haber cycle of the energy change that takes place to form an ionic compound, right? Which means that if you take this one all to the subsidiary steps, the enthalpy of formation, right? Delta H formation of NaCl should be equal to enthalpy of atomization plus ionization energy plus another enthalpy of atomization for the chloride plus electron affinity plus lattice energy. Is that okay? Now this energy value should be given to you. So you just put them in and then you work it out. The more negative your enthalpy of formation is, the more stable the compound form. Is that okay? Because if you are forming the two compounds, you expect that energy, because the two species are not stable, it means that they are what? Before a species is stable, it means that it has low energy. Is that okay? So it means that for them to be stable, they must give up those energies to achieve that stability. So the energy changes at the end of the reaction. If the overall delta H of formation is negative, it means that such a compound is stable and can easily be formed from that process. Is that okay? But what he's trying to put across is not the properties, but it's just the enthalpy change that takes place to form the compound. Is that okay? But let's come back to the properties. Yeah, properties. Yes.
Yeah, ionic compounds are crystalline solids at room temperature due to the electrostatic forces between the atoms.
Yeah, they are supposed to be crystalline solids at room temperature. That's important because a substance may be solid at this temperature. If you send the same substance to a higher temperature, it may not be solid anymore. Is that okay? And then substances are solid if only the force that holds them are stronger. Is that okay? So the stronger the force between two things, what that is around that, even the clothes you wear, it's because of bonds. If those bonds are not strong enough to hold them together, they might have been living apart. Is that okay? So anything around that is the way it is because the force of attraction either between the atoms or the molecules are strong enough to bring them together, so they stay as a unit. If the force is able to be broken down, then you're able to convert such a substance to another form. Is that okay? Right. So they are crystalline solid are rooted because of the strong electrostatic force of attraction between the oppositely charged ions. Right. Any other properties? Yeah. Good. So they should have high melting or boiling point. Why should they have high melting or boiling points? Ionic compounds. Why should they have high melting or boiling points?
other forces are very strong.
Yeah, because the force of attraction between them are very strong. The electrostatic forces are strong forces, and therefore, but that is not just between the atoms. Because I've said that if I have sodium chloride as a salt, the force between the sodium and the chloride ions are interatomic, but the forces between the sodium chloride themselves are intermolecular. Is that okay? All those forces put together will give the compound if it is a higher melting or boiling point. So the stronger the forces put together, the higher the melting or boiling. Because the force of attraction between them are strong, they should have higher melting or boiling point. If you put salt on fire, or ordinary fire, it will take months for it to melt. Is that okay? But you need a very high temperature to do that, which Bunsen burner or any other flame cannot do. Only a higher voltage will easily do that. Right? So they have high melting or boiling. Any other? Any other? Apart from crystalline structure, high melting or boiling points. Any other? I hope all of us have watched this movie, The Three Idiots.
Yes.
Yeah, if you have watched The Three Idiots, why was the gentleman electrocuted? When he placed on the spoon, why was he electrocuted? He has no connection with the spoon by virtue of electrical wire, but he got electrocuted. Why was he electrocuted? Because the urine contains salt, which is ionic. Is that okay? So we expect that ionic compounds conduct electricity, not in a solid state, in their in aqueous or molten state. Is that okay? So had it not been because of the ions in the urine, nothing will happen to it. Is that okay? Even the water has a very little conductivity, but that will not electrocute it if ions are not in there. Right? Yeah, it's the same thing. So if sweat has salt in it, and your sweat, your bare body touches an exposed cable, you should get electrocuted. Now, because the sweat also has salt in it, that can take that electricity. Okay. Yeah. Any other?
They are soluble in polar solvents.
Yeah. Ionic compounds are soluble. They are soluble in polar solvent. Right, what do you mean by that? What you mean by that is that if you put sodium chloride in water, it should dissolve. Is that okay? But if you put sodium chloride in kerosene or diesel, it will not dissolve. Is that okay? What is the reason? Because water is polar and ionic compounds are usually polar. Polar means that if you take ionic compound, let's say N is here, this is positive, this is negative. Now within water, the oxygen is also partially negative. Is that okay? So we say this is negative, and hydrogen is also partially positive. So if you put this in water, the two should be able to interact. That is, the negative oxygen here should be able to pull the positive sodium to each other, to itself. And then also pulling this one to itself. In that case, they can break the lattice energy that holds the ionic crystal together. Is that okay? Right? Or you can also look at it this way. If you put a substance in water, the water should generate enough energy to overcome this force. This is the force that holds these particles together to form this. So if the water is able to generate what we call enough hydration energy, that is delta H hydration. The energy, delta H hydration should be able to overcome the lattice energy before dissolution can take place. So if anything can dissolve in water, it means that the energy produced by the water molecules is able to break down this force that holds the particles together for the thing to dissolve. Other than that, the two must interact by polar ends. One polar end pulling the other polar end. And that way breaking the force that holds the particles together. Okay. So sodium chloride will not dissolve in diesel because sodium chloride is polar, diesel is non-polar. So the two cannot interact. Or we can also say that enough energy is not generated by the diesel to break the lattice energy that holds the sodium chloride crystals together. In that case, there will not be any dissolution, right? So every ionic compound should dissolve in polar solvents like water, but they will not dissolve in non-polar solvents like kerosene, or diesel, or turpentine, or tetrachloromethane, etc. Right. I think that's okay for the properties. Yeah, question, yes.
When I was reading in the code series, it was that ionic bonds are non-directional. I wanted to add that this is the meaning of the non-directional.
Okay. Yeah, for a bond to be directional, it means that the atoms are arranged towards the corners of a regular, maybe a polygon. Is that okay? For example, if you take a CH4, CH4 is directional because the bond between the carbon and hydrogens are arranged towards the corners of a regular tetrahedron. So there's an angle of separation between them, which is 109.5. But if you take ionic crystals, for example, because the atoms are not arranged towards any, maybe that kind of polygon structure, right? We're saying that the bond between them are not directional. In that case, there's no angle of separation, or there's no definite angle of separation between the ions in the bond. The only thing is that the ions are placed at regular positions so that they will give a crystal lattice. Is that okay? But there's no definite measured angle of separation between maybe a sodium and a chloride ion and a ionic crystal. But between a carbon and hydrogen atom in a covalent bond, there's an angle of separation which can be measured. In that case, they are direction. Is that okay? Yes. Any other question? Any other question? Then we have finished the topic, the subtopic on ionic or electrovalent bond. Any other question from anyone? Yes.
Rubber and turpentine.
Rubber and turpentine.
Yeah, rubber will dissolve in turpentine.
Yeah.
So at that point, is rubber a polar solvent?
No, because the two are non-polar. Is that okay? So we say that in summary, you can say that it dissolves non-polar. So that if you use oil paint to paint your room and you have paint stains on your body, you cannot use water to wash it. It will not go. Because water is polar, oil paint is non-polar. You use kerosene because kerosene is also non-polar. In that case, the paint will go. Is that okay? Right. Any other question? Any other question? Okay, so let's summarize. In summary, okay. Yeah, in summary, we say that a bond is anything that holds two things together. Is that okay? And in chemistry, that type of bond is what we call a chemical bond. And a chemical bond could be of two main types. Those that are found between atoms, which are interatomic, and those that are found between molecules, which are what? Intermolecular. And the interatomic bonds are also of three types. They can be ionic or electrovalent, or covalent, or metallic. Is that okay? And we look at what the ionic bonds are. We say that they are what? They are electrostatic force of attraction between two oppositely charged ions, cation and anion, for them to achieve stable inert gas electronic configuration. Right. And then we went on to look at how they are formed. Right. That is by electrostatic force of attraction between a positively charged ion and negatively charged ion. Right. Then we went on to look at the units of pair and the lattice size. We said that the coordination is a 6-6 coordination. That is, each sodium ion is surrounded by 6 other chloride ions in a face-centered cubic lattice. Right. And then we went on to look at the enthalpy change that takes place. Right. We said that there are so many energy changes that takes place that give rise to the formation of any ionic compound. When you put all those energy changes together and the enthalpy change, the overall enthalpy change is negative, it means that the ionic compound form is highly stable. But if the enthalpy change is positive, it means that the ionic compound form is highly unstable. Is that okay? Then we discuss the properties. They are crystalline solids, they have high melting points, they are soluble in polar solvents, and then they are non-directional, and they conduct electricity only in the molten or aqueous. Which means that if I should hold a solid sodium chloride and I should touch a bare electrical cable, nothing should happen to you. Because in that case, the ions are not free to move about. But if you put the same thing in water before you touch the cable, you shouldn't get electrocuted because the ions can move about now freely without it. Right? Because the ions are not able to move about, they cannot carry the charges along. Unless they are moving, they can carry the charges along. Then they can conduct electricity. Right? So at our next lesson, we'll investigate the electrical conductivity practically in the lab. And then we'll also try to build models to give the exact structure for the ionic compounds. While we say they are face-centered cubic lattice. Right. Okay, we've come to the end of today's lesson.